let's find Z transform of this particular signal using appropriate properties. So here this 1 by 2 raised to n can be a bit modified as n minus 3, that is 1 by 2 raised to 3 into 1 by 2 raised to n minus 3. Why we have to do so? Because we require, so that is in the form of a same format, that is 1 by 2 raised to n minus 3 into u of n minus 3. So therefore your 1 by 2 raised to n minus 3 into 1 by 2 raised to 3 can be written as 1 by 8 into 1 by 2 raised to n minus 3, and the remaining terms as it is you can write n square into u of n minus 3. So here what we have to do is systematically, if you have written, then it will be 1 by 8 outside constant term n square into 1 by 2 raised to n minus 3 into u of n minus 3. So here you can apply, as we know, that is 1 by 2 raised to n into u of n z transform will be 1 divided by 1 minus 1 by 2 z inverse. Similarly, now we have 1 by 2 raised to n minus 3 into u of n minus 3. So which property we are supposed to apply? Here we have to apply a time shift property. Here only n was there, n is shifted to n minus 3. So therefore time shift property will say that z raised to n naught, this is n minus n naught we can take, so z raised to n naught, that is z raised to minus 3, okay, into x of z. So as we know that x of minus, that is z raised to minus 3 we can write, and x of z we have. So similarly we can make use of that, that is 1 by 2, that 1 by 2 raised to n minus 3 into u of n minus 3 is z transform will be z raised to minus 3 into x of z, that is z raised to n naught. Here n naught is the n minus n naught or n plus n naught, it is n minus n naught, so n naught is minus 3, therefore it will be z raised to minus 3 into 1 z transform of that function, which is 1 divided by 1 minus 1 by 2 into z raised to minus 1. So this is not sufficient for us, only we have got till this much, that is z transform of this. Now we have to multiply with n square, that is n into n. So while taking that, you can further simplify this equation, so that we have z raised to minus 3 divided by 1 minus 1 by 2 raised into z raised to minus 1. This can be simplified. This we can take as 1 by z cube into here you can write 1 minus 1 by 2 z raised to minus 1. Okay, so simplify this, z cube you bring inside, then it will be 1 divided by z cube minus 1 by 2 into z square into z cube into z raised to minus 1 is nothing but z square. Therefore it's a z transform of 1 by 2 raised to n minus 3 into u of n minus 3's z transform is this, that is 1 divided by z cube minus 1 by 2 z square. Okay, now we have to take multiply that with the n. So we have a n square, but now let's take only one n. So just multiply here, that is n into 1 by 2 raised to n minus 3 into u of n minus 3. Then if you have multiplied with the n, then we have a one property, that is differentiation property. Okay, using differentiation in z domain property we can write, so this entire signal's z transform will be minus z into differentiation of that signal, means x of z, which is 1 divided by z cube minus 1 by 2 z square. So let's simplify this. Here minus z as it is, 1 divided by z cube minus 1 by 2 z square we have. So differentiate it, that is in the form of u by v form. So, or you can say numerator by denominator. So denominator square, okay, denominator square then denominator square, then denominator as it is, into differentiate the numerator. So 1 is there, the differentiation of constant is 0. So minus, keep the numerator as it is, that is 1, into differentiate the denominator, that is it is z cube minus 1 by 2 z square. So that if you are differentiating, z cube differentiation is 3z square, minus is there, then 1 by 2 as it is, z square differentiation is 2z. So simplify this, it will be 3z square minus z. Next, write systematically by taking this z minus z inside. So observe in the first factor, it is multiplied with a 0, so this entire term goes to 0. We have minus 3z square minus z, so take this minus inside as well as z also inside. Then it will be minus into minus plus, plus 3z cube, okay, minus into minus, again it will be minus z square, divided by denominator as it is, that is z cube minus 1 by 2 z square whole square. So again we not have only one n, we have one more, therefore it should be multiplied with one more n here, that is n square, okay, n square into this. So then using the same property, that is the differentiation of a z property, z transform property, then we can write minus z into differentiation of x of z. So now x of z is not earlier one, x of z is this one which we had multiplied with n. So now we have to take this x of z here, that is 3z square minus z square divided by 3z cube minus z square divided by z cube minus 1 by 2 z square whole square. So let's differentiate this, keep minus z as it is, okay, differentiate, this is in the form of numerator by denominator. So square the denominator already it was z cube minus 1 by 2 z square whole square, that square we have to take, okay. And the next in the numerator, keep the denominator as it is, that is z cube minus 1 by 2 z square whole square, keep as it is, and differentiate the numerator, that is 3z cube differentiation is 9z square, 3 into 3 z square, so therefore it will be 9z square. Z square's differentiation is 2z, minus, okay, minus, keep the numerator as it is, that is 3z square minus 3z cube minus z square as it is, into differentiation of this. Observe this term is a whole square, so first to differentiate that, it will be 2 into the same factor or a same value, that is z cube minus 1 by 2 z square, into differentiate inside this factor, that is differentiate this, that is 3z square minus 1 by 2 into 2 into z, so it will be z only, okay. And now simplification we have to do. For that what we can do is, observe in the numerator we have z cube minus 1 by 2 z square in this factor, okay, in the second factor, as well as in the first factor. In the first factor it is a square, one term of z cube minus 1 by 2 z square you can take outside from this factor as well as in the second factor. Then what we can get is that simplify what we have here is a further more simplification that we have written like this. It was 2 into z cube, so this 2 has to be multiplied with this I have done. So write systematically. So as we have said, take z cube minus 1 by 2 z square, one factor from this, okay, one term of this first factor, and from this second factor also we have, that is z cube minus 1 by 2 z square. Take that term outside first, okay. Once you have taken out, what is there inside this first factor? Inside this first factor only we have z cube minus 1 by 2 z square as it is. One term we have taken out and one term will be remains here. and then in the same factor we have 9z square minus 9z. Okay, come to the second factor. We have 3z cube, so sorry, this should be 3z cube minus z square. Okay, so then this 2 you can take inside, because this 2 we have already taken out. Okay, 2 into 3, that is 6z square minus 2z. Okay, so once you have taken this out, this and denominator is also same, so it is z raised to 4, 1 you can get cancelled. So in the denominator this factor cube will be remained. Okay, that you can write systematically. Okay, and then now before multiplying with this minus z inside, take this, there are two factors, this and this, expand this, that is z cube into 9z square is nothing but 9z raised to 5, and z cube into minus 2z, it will be minus 2z raised to 4. Then this into this factor, distributive property we are applying, 1 by 2 z square into 9z square will be 9 by 2 minus 9 by 2 z raised to 4, and then we have to multiply with this, that is minus into minus plus, plus 1 by 2 into 2 will be 1 z cube, and then minus sign keep as it is in the second factor and expand these two, that is 3 into 3z cube into 6z square is 18z raised to 5. 3z cube into 2z is minus 6z raised to 4. Then second term, that is minus z square into 6z square is minus 6z raised to 4. Minus z square into minus 2z is plus 2z cube. Then denominator is one factor has less. So z cube minus 1 by 2 into z square whole cube. Now minus z into, for the simplification what we are going to do is this minus sign we are going to take inside. So first three terms we are going to simplify again. So observe here, this is 2z raised to 4 and 9 by 2 raised to z raised to 4. So simplify this, 9z raised to 5 as it is, minus 2z raised to 4 minus 9 by 2 z raised to 4. It will be, take a LCM of this, then it will be 4 plus 4 minus 4 minus 9 divided by 2, that is minus 13 by 2 z raised to 4. So simplify this, it terms remains the same, minus sign just take inside. Before taking take along with that and simplify inside terms, that is minus 18 z raised to 5, and here you can observe minus 6 z raised to 4 minus 6 z raised to 4, it will be minus 12 z raised to 4. Take minus sign inside, it will be plus z raised to 12 plus 12 z raised to 4. Minus into plus will be minus 2 z cube. So divided by denominator. So here again a simplification, that is z raised to 5, and here is z raised to 5 and z raised to 4. Here we have z raised to 4 coefficients. So that we have to simplify. If we are simplifying that, so what we get is 9z raised to 5 minus 18 will be minus 9z raised to 5. And next minus 13 by 2, minus 13 by 2 and plus 12 will be what? It is, you can take minus 13 plus 24 divided by 2. What is this? It will be 11 by 2. 11 by 2 z raised to 4. Okay, and the next term we have is z cube minus 2z cube will be minus z cube. That terms we have here divided by denominator as it is. Then now what we can do is take a minus z inside. Sorry, keep z as it is. From this factor take z cube outside. While taking z cube outside and then multiply with this z, it will be, when you are taking already z is there, you are taking z cube outside, then here it will be z raised to 4. So what all remains inside? So it is minus sign you take inside, it will be minus minus plus 9 z raised to it should be minus 3. If you have taken out, it will be 2. I'm sorry. Okay, this is minus 5. 5, here it will be 9z square. Okay, 9z square minus 11, when you have taken z cube outside, it will be z remained and plus 1 remains divided by denominator. Now we not have only this much, that is only your n square into, that is n square into 1 by 2 raised to n minus 3 into u of n minus 3. This is the z transform of this terms, but we have 1 by 8 also by using a linear property. So its z transform will be, that is 1 by 8 n square into 1 by 2 raised to n minus 3 into u of n minus 3. Z transform will be linear property. If you are taking any constant multiplying with the signal, that constant term will remain same, 1 by 8 into x of z. Therefore 1 by 8, what is x of z is this, that is z raised to 4 into 9z square minus 11z plus 1 divided by z cube minus 1 by 2 z square whole cube. Okay, and next we'll see the other numerical, that is x of n is equal to, same using using z transform properties, we have to find z transform of the signal. X of n is equal to 1 by 2 raised to n into u of n, convolution with 1 by 3 raised to n into u of n. What we can do here is, so let's take 1 by 2 raised to n into u of n as x1 of n. Okay, and another signal, that is x2 of n, we can say, which is 1 by 3 raised to n into u of n. Let's find out the z transform of this and this separately, and then we can apply convolution property. Okay, now as we know, x1 of n, we have taken it as 1 by 2 raised to n into u of n. Its z transform will be 1 divided by 1 minus 1 by 2 inverse, z inverse. Okay, similarly x2 of n's is 1 by 3 raised to n into u of n. Its z transform will be 1 divided by 1 minus 1 by 3 into z raised to minus 1. So now apply what is x of n here. X of n is x1 of n convolution with x2 of n. So here, as we know the property, this is a z transform of a first signal, this is a z transform of the second signal. Now as we know that a convolution property says that x1 of n convolution with x2 of n's z transform will be x1 of z simple multiplication with x2 of z. Therefore we know x1 of z separately and x2 of z separately. So here we can write directly that x1 of n convolution with x2 of n will be equal to x1 of z into x2 of z. Therefore this convolution z transform will be 1 divided by 1 minus 1 by 2 z inverse into 1 divided by 1 minus 1 by 3 z raised to minus 1. So you can simplify this and directly you can write 1 by 2 z raised to minus 1 into 1 minus 1 by 3 z raised to minus 1. Okay, this is your, now we have found out individual z transform and then we have applied a convolution property for this. So simply keep as it is. Okay, so this is about the convolution. If you have a convolution signals, it's to find out its z transform will be easy for us. Individually each signal's individual z transform we have to find out, and then simple multiplication. And now we'll consider another one. Determine the z transform of the following signals and sketch the ROC. Here there are two signals. Let's find out this z transform. Okay, first signal is x1 of n equal to 1 by 3 raised to n, where this is true when n is greater than or equal to 0. What do you mean by this n is greater than or equal to 0? It means from the signal starting from 0, it will be, this signal will be 1 by 3 raised to n. And then what about another signal we have in the same, that is 1 by 2 raised to minus n when n is less than 0. Means here we have both the side signals. One is from 0 to infinity also we have, okay, and another one is from this minus 1 to infinite minus infinity also we have. On both the sides we have a signal. That's the meaning of this signal. Here what you mean by this is x1 of n is present 1 by 3 raised to n magnitude. It is present where n is greater than or equal to 0, and another signal is 1 by 2 raised to minus n where n is less than 0. That time also this signal is present. Therefore what we have to do is, okay, we have to find out this Z transform. Let's find out what about this second problem they have given, that is x2 of n is x1 of n plus 4. Whatever you will find out this transforms, that signals n plus 4 has to be taken. Means time shifting, we can use time shifting property, because x1 of n plus 4 it is. Whatever the signal you get, that has to be taken to n plus 4. Let's deal with the first one now. As we know, this signal has to be written in this particular manner, that so x1 of n can be written as, observe, this is 1 by 3 raised to n where n is greater than 0. Therefore x1 of z transform of the first signal will be summation of n is equal to minus infinity to plus infinity. Here we have x1 of n into z raised to minus n. Here we supposed to substitute what you mean by this x1 of n. Now here we have x1 of n, same signal we have two factors. Okay, let's find out it. Let's write that. First one, a summation of first one will be writing, which is n is equal to n is greater than or equal to 0, means from this to infinity. Therefore it will be, first signal will be from 0 to infinity. What is that signal? Which is 1 by 3 raised to n. This is your x of n. Okay, this is first signal. Another signal also we have, that is true when n is less than 0. Here it is n which is less than 0. So up to minus infinity also we have that signal. So how we can take it? You can take it from minus infinity to minus 1. Don't take up to from minus infinity to 0, because already 0 signal we have considered here. Okay, therefore it is up to minus 1. So second signal will be from minus infinity to minus 1, and that signal is 1 by 2 raised to minus n. This signals into minus n is z raised to minus n we have to do. That is here. Okay, so from this x1 of z can be written as, so this is the formula of z transform. In that we can write 1 by 3 raised to n into z raised to minus n is present when n is greater than 0, which is 0 to infinity. Then plus another signal we have, that is n is less than 0, which is 1 by 2 raised to minus n into z raised to minus n, and its limit is from minus infinity to minus 1. So further we can simplify easily that make a small changes. Here it will not be changed much. Simplify it, 0 to infinity, and then 1 by 3 raised to n into z raised to minus n. You can take z raised to minus 1 whole raised to n you can write, plus then just I am interchanging the limits. Then there is no change in the signal. Okay, but if you are interchanging the signal with the sign, then only it has to be multiplied with the minus sign. Okay, now minus 1 to minus infinity, 1 by 2 raised to minus n into z raised to minus n. Take that minus n outside, and then it will be 1 by 2 z raised to minus n. But what we are doing is we are changing its sign of the limits. Then it is not from minus 1 to minus infinity, it will be from 1 to infinity. Therefore you can write 1 by 2 z raised to minus n whole raised to minus 1. Then it will be 1 by 2 z raised to n only. Okay, then we know for both the terms, right here, that is 0 to infinity, first term 0 to infinity 1 by 2 3 1 by 3 z raised to minus 1 whole raised to n, plus 1 by infinity, which was minus 1 raised to minus 1. If you write, it will be 1 by 2 z raised to n. So apply, as we know, 0 to infinity alpha raised to n formula is 1 divided by 1 minus alpha. Condition is alpha should be less than 1. Okay, here what from we know this one also, that is summation of 1 to infinity alpha raised to n is nothing but alpha divided by 1 minus alpha. Okay, so same formula we have to apply here, that is first one is 1 divided by 1 minus alpha plus alpha divided by 1 minus alpha. Just to simplify this, we are going to multiply and take a LCM of this. When you are taking LCM, it will be 1 minus 1 by 3 z inverse into this factor. Okay, so just multiply this here to here and here to here. That will be 1 minus 1 by 2 in the numerator, 1 minus 1 by 2 z plus 1 by 2 z into 1 minus 1 by 3 z inverse. So simplify this term. Let's simplify. 1 minus 1 by 2 z as it is, plus 1 by 2 z you take inside, that is 1 by 2 z minus plus minus 1 by 2 into 1 by 3 will be 1 by 6. Z into z inverse will be 1. So therefore simplify here, these two will get cancelled. 1 minus 1 by 6 will be 6 here. So 6 minus 1 divided by 6 will be 5 divided by 6, and denominator as it is. Let's take that. This will be 5 by 6 divided by denominator. Therefore ROC will be, as we have said earlier, it should be first alpha should be less than 1, where alpha was 1 by 3 z raised to minus 1 should be less than 1, and your 1 by 2 z should be less than 1. Therefore simplify this. Here it should be z should be greater than 1 by 3 and z should be in the second case less than 2. Therefore this is your ROC. ROC should be greater than 1 by 3 and less than 2. So we can draw now only, but we have another one which is linking with this. Together we are going to draw this ROC. Let's take second. They have asked us to find out x2 of n, which is equal to x1 of n plus 4 using time shifting property. As we know, the time shifting property is x of n plus n naught will be equal to z raised to n naught into x of z. As we know, here in the place of n naught, here we have a 4. x1 of n plus 4 will be z raised to 4 into x1 of z. Already we have calculated it. So what is the z transform of the first signal? Therefore, observe, this is x1 of n plus 4 they have asked. That is nothing but your x2 of n. Therefore, so its z transform will be z raised to 4 into x1 of z. This we know, z raised to 4 into 5 by 6 divided by this denominator, that is x1's z transform. Okay, so now ROC is similar for both the cases, and now ROC will be greater than 1 by 3 and less than 2. Let's draw this. This is 1 by 3, one pole, and this is another pole as 2. Then take a circle for both the poles, make a radius of that and take a circle. Then your ROC should be within this. Therefore your ROC will be within this place of z transform of a z plane. Okay.